Imagine trying to count the stars in the night sky. It's an impossible task, right? There are just too many. Chemists face a similar problem when dealing with atoms and molecules. These particles are incredibly tiny. It's impractical to count them individually. This is where the mole comes in. The mole is a unit of measurement in chemistry. It helps us deal with the vast numbers of atoms and molecules in a manageable way. Just like we use a dozen to represent 12, we use a mole to represent a very large number. How large is a mole? A mole is equal to 6.022 times 10 to the power of 23 entities. This is called Avogadro's number. It's a mind-bogglingly large number, but it makes working with atoms and molecules much easier. The mole concept allows chemists to work with measurable quantities of substances. This is crucial for conducting experiments and making accurate predictions in chemical reactions. Let's talk about molar mass. Molar mass is the mass of 1 mole of a substance. It is expressed in grams per mole. To calculate the molar mass of a compound, we add up the atomic masses of all the atoms in its formula. Let's take ethanol, C2H5OH, as an example. Ethanol has 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. The atomic mass of carbon is 12.01 grams per mole. Hydrogen is 1.01 grams per mole, and oxygen is 16 grams per mole. Therefore, the molar mass of ethanol is 2 times 12.01 grams per mole, plus 6 times 1.01 grams per mole, plus 1 times 16 grams per mole, which equals 46.08 grams per mole. This means that 1 mole of ethanol weighs 46.08 grams. Avogadro's constant is a fundamental constant in chemistry. It represents the number of entities in 1 mole of a substance. This number is 6.022 times 10 to the power of 23. To put this number into perspective, imagine you had 6.022 times 10 to the power of 23 grains of sand. That's a mole of sand. It would be enough sand to cover the entire Earth to a depth of several kilometers. Avogadro's constant bridges the gap between the macroscopic world and the microscopic world of atoms and molecules. It allows us to relate the mass of a substance to the number of particles it contains. Section 4. Ethanol and the mole. A practical example. Let's revisit our ethanol example. We know that the molar mass of ethanol is 46.08 grams per mole. This means that 46.08 grams of ethanol contains 1 mole of ethanol molecules. If we had 23.04 grams of ethanol, we would have half a mole of ethanol molecules. Similarly, if we had 92.16 grams of ethanol, we would have 2 moles of ethanol molecules. The mole concept allows us to convert between mass, moles, and number of particles using simple formulas. This is essential for stoichiometry, which is the study of the quantitative relationships between reactants and products in chemical reactions. Section 5. The mole concept, a recap. The mole concept is a fundamental concept in chemistry that allows us to work with the vast numbers of atoms and molecules in a manageable way. A mole is equal to 6.022 times 10 to the 23rd entities, which is known as Avogadro's constant. The molar mass of a substance is the mass of 1 mole of that substance. It is expressed in grams per mole. To calculate the molar mass of a compound, we add up the atomic masses of all the atoms in its formula. The mole concept allows us to convert between mass, moles, and number of particles. This is essential for stoichiometry and many other areas of chemistry. Section 6. Conclusion: the mole's significance. The mole concept is as fundamental to chemistry as the telescope is to astronomy. It allows us to explore the universe of atoms and molecules with a level of precision that would otherwise be impossible. Whether we are studying chemical reactions, analyzing the composition of matter, or developing new materials, the mole is an indispensable tool for chemists. It is a testament to the power of human ingenuity to develop concepts that help us understand and manipulate the world around us.